Chrome. I need to be in YouTube. Do I need to be in YouTube? No, I think it, because YouTube knows that I set up my stream, so I think it's still started streaming. Hello everybody. Hopefully that seems green, so it seems to be streaming. Yep, that's got the audio right. So I can now go to Golang, and Golang has installed.
Yeah, or something requesting something.
Ah, approval. Yes. Haha.
Oh, scary! Installing stuff.
Oh no! Oh no! And so if we go to that one and go thing, and do we have where I was recently? Nope. It doesn't seem to have stayed where I was, so that's you. So this is the Golang repository that we're looking at, and there's some of the main package. And we now have Golang has finished. Yay! Okay, so and then so we now got Golang installed on the machine. So what else do I need to be able to? Yeah, Git. Yep. So I've got the. CDD colon, that's better. CD git, CD. Now what was it called? Your repository is Discord. Discord, that's right. Discord. So we've got I've got the repo down, and so then I can.
And it's within your Go workspace.
Yeah, no, it won't be with my Go workspace, so I have to start Go Lang. How do I start? Oh, so I've installed Golang. Where did it go?
So I'm not sure for Windows, but for Linux, it's a specific path in your home directory where you have to list all your stuff.
Right. So
I think you can just do echo go path to see where you need to put the library.
Capital or go path?
Yeah, it's supposed to be an environment variable.
So
or not?
No, that's an environment variable would need the string, and it doesn't recognize go path like that. No. So okay, if we go back to visual thing, we can go to here, and we can go to add one of those and go Golang. Well, I keep getting the G wrong. So having installed it, so I've downloaded it, and there should be a README on what it's done. Okay, programming languages. Okay, nope, that's not what I'm looking for. I would have expected it to go Lang. Let's do a search for Go. Where did it put it? Let's do a search for installing Golang. Getting started. Okay, so with Windows, there's things. So with Mac is going for 2 installations and something from source. Okay. MSI file, which is what I got. C go bin. Installer should be in go bin directly in your path. You can restart any open commands. Oh, so it's C go bin. Right. So from within, so I can actually go to this, and it should be C:/go. There's C bin, but slash. That should be. Okay, so it's not giving. Oh, right. This is because Bash doesn't see the actual C directory; it sees its version of C directory. So I think because this is the C.
Yeah, because that
Yep.
doesn't look like
That's
C.
not my actual C. No. So because that is my actual C. So I now have go there. So cd go. So there and go bin. Right. So there is. So I'd need to add that to my environment variables. Right. So
well, you could try to just write go and see if it runs something. Yeah, okay. Yeah.
so it knows it's there, and I mean I could go and then go to the d : / where your.
Oh, have you done any Golang before?
No.
Okay, because with Golang, you
Mhm.
can't just put your libs anywhere. It has to be within the Go
The
directory.
go directory. Yeah.
Yeah.
So if this is the go directory, then I should bring your libs over into here.
Yeah, so before you do that, you
Yep.
have to go into Go one directory back,
Right.
and then go into source, and then take a list.
So having listed this source. Oh, you guys aren't seeing any of this. So, let's see if I can get
Supposed to show.
display capture, and then go OK, and then try getting that display, and OK, and no, it won't display capture while I'm on this machine while I'm doing that. So I have to do window capture. So so sorry, people, you're kind of. You're having trouble. You can kind of see in the background if I do this, you can see what's going on a little bit. Okay, so within source.
Yeah, so you're supposed to put it in a folder called
Yep.
github.com.
Right, there is no folder to object, so I can make dir. Make dir github.com.
Inside GitHub, you will write my name, Anders Filling.
So make dir on your name. Yeah. Anders. We'll just call it Anders.
Lowercase.
Ah,
It has to be the same as on GitHub.
okay. Anders.
F-Y
F-Y
L-L
L-L
I
I
L
oh I L
N, not L. G.
right.
And then
Okay.
you can do a git. Oh, you can see the into that, and then you can do git clone Discord into that.
Right, so then I can do my git clone, which I had that one. Nope.
No.
Nope, that's the sheets. Nope. Okay, so it's a git clone of your directory, which if I go up to here is copy that and paste it there. Right, so it's getting that, it's getting that, it's getting that.
And then you can go into the Discord folder
Mm-hmm.
and just do a go test.
We can fingers crossed that works. It's currently trying go test. Ah, it did something.
Yeah, and do a git checkout.
Git check out.
Feature,
Sure.
and I think you can just hit tab and auto complete it. Yeah.
Yep. HTTP requests. Switching to the new branch. So switch to the new branch, and then do go test.
I think you need to go get and then
Oh yeah. So a git pull.
no, just go get that to get the go dependencies.
Go get. No. What do you? So go
Yeah.
go get. Right. So it gets the dependencies for the thing it's currently in. So it's currently trying to do that. So we'll switch over while it gets the dependencies. We can go over here. Done, and then go test.
Yeah.
No test files.
Yeah, that's correct. Yeah.
Okay.
It's working, yeah.
so the test is a no test, right? That's exciting. Now, for some reason, I'm still trying to work out why it won't let me do display captures and on the display when I've got it duplicated here. I think it's something to do with the capture of windows. Though this started up with it fresh, so it started up knowing that it was like this. So I'm not sure. But okay, so we can add, the window capture, because if you're going to be doing things in that that window, we can put that window in here. So you've got that window in this window to talk about stuff. Right. Okay. Discord. Gourd. Right, okay, so come and grab a seat. Okay, so we're going to be talking about Discord. So so we've just set up, seeing this is quick, we've set up the Golang environment. So most of you had the cloud computing course. Actually, some of you didn't. We did. Some of you did. So there, the students learned to use Go and use Google's language. I actually just had a discussion, an email last week, that C# is something you guys should be upskilling at, because there are a lot of C# jobs out there at the moment. If you want a programming job, knowing some C# is very useful. So we might have to do some C# discussions at some point. But Go is also a very useful language, particularly for doing things on the web. So, Andrew.
Yeah. Okay. Discord. Does everyone here know what Discord is?
Yeah.
Okay. So the Discord API consists of mainly two parts, which is the REST API and the socket API. The REST API is what you use to get objects or do requests, send messages, that sort of stuff. And then the socket API is to keep your clients up to date with the Discord state.
So you guys can understand, sort of, yeah, so one, you've got the API where you kind of communicate with, and you've got to have the socket so it can talk to you.
Yeah.
So you can listen.
Yeah. And within that, there are a few requirements like rate limiting and caching. So if you don't do the rate limiting and you don't cache properly, Discord is just going to ban your client, essentially. So that's kind of important. The stuff you can do with Discord API is to essentially make chatbots or react to messages, anything you want, really. You get access to everything that you see on the Discord client. And yeah, any questions about the Discord API? Nothing?
So for example, I've used Discord, and we're doing a role-playing game on Discord for a bit, and it had a random number, a die rolling bot, right? So someone wrote a die rolling bot for Discord, and you could just ask the bot to roll a sequence of dice, and it would randomly run those dice and then give you the result, right? So as a nice tool for when if you're doing an online role-playing game, that's a bot that's quite useful to do some activities. But you can also have bots where you can ask them things. I had my first meeting organised by Evie. Have any of you had a meeting organised by Evie? Evie is an online assistant, and so it's an AI developed to be able to understand requests for meetings and use Outlook to set up meetings and send emails out saying, are you available for this, and when you say yes, to set up the meetings and manage timings of meetings, right? So it's a bot to organise meetings, right? So I chatted with her. It seemed like a good secretary. But yeah, so this kind of thing is what you could program for Discord. You could have a bot there that would organise meetings or connect to Trello or any of these sort of things. So, okay.
Yeah. So what I've done is written a library so you can more easily communicate with the Discord API, and then handles caching and rate limiting, so you don't have to bother with those. And the most simple way to say connect to the Discord lib is just this if you use my library. So every time you connect, you need a Discord token, and you get those by making a Discord application on their website. I think that's here. Yeah, here, and then just my apps. You need to be authenticated or logged in, and then you can get a application going and get a token to sign in. So once you're in, you could do add listeners to the events from the socket API. This is event driven, so you do need to handle everything asynchronous. Nothing is synchronous with the Discord except the REST API. And yeah, that's pretty much it. Everything in... Does anyone here use Golang? Yeah, so my lib is completely asynchronous. It does mutex.
So you've basically written a library to easier create bots, right?
Yeah. So a quick guide, let's see. To use the REST API, I did draft up this yesterday just to show how it works, the behavior. And you can see it deals with caching and checks the rate limiter before you get a response. The issue now is that since mostly no one here uses Go, I'm not sure how specific I should be about this.
Well, so I think in terms of discussing the rate limiting and the caching, right? So when you're using another service, right? So for example, if you're going to be using Google Image Search or something like that, right? They usually have detections to see if you are using it in an unusual way, right? Or if you're abusing the service. And so this rate limiting is basically saying, you know, you can use up to this amount, but if you use more than this amount, then we'll block you, right? Now, one way they could potentially do the whole, the maximum you can use is say 100k a second, right? And that would mean everyone was slow and no one could do anything quickly. But instead of doing that, they go, well, actually, no, we'll let you use like the maximum bandwidth, but you better not use more than 10 meg a second, right? Which means you can, or 10 meg every 20 seconds or something, right? So they let you go fast, but they don't want you to go fast all the time. Just at some point you're supposed to rate limit yourself, but you can have spikes that go up. Yep.
So someone is telling me that the stream is blocked by Git and the picture.
Oh. Aha, the picture is being blocked because that is on top. So there we go. Yep. So that makes the picture a bit easier to see. Thank you for watching the stream. It's a team effort to have the external thing. So yeah, so in terms of this asynchronous, one of the critical things you guys need to be able to do as a professional programmer now is be able to think asynchronously. Right? So this approach of having Golang, having to think of your library as completely asynchronous, this is the new normal. Right? The new normal would be cloud-based microservices, asynchronous.
Yeah.
Yeah. Never being able to be sure when things are going to complete or what order they'll come in, and so just having to write things kind of very independently. Okay. So basically, think of what you did in the operating systems course with like a couple of flags and mutexes, and then ramp that up to everything you do. And it becomes difficult, right?
Yeah, it becomes a little difficult and confusing at times, but once you get the hang of it, it's kind of, you can't go back.
It gives a lot of freedom once you've worked it out. Now, professionally, you do this diagram, right? So this diagram that you guys can see. This allows you to kind of understand what's going on.
Yeah, so this is the behavior of communicating with the REST API using my library. So, you ask for a user ID and you get a Golang channel, which is a little complex, but essentially it doesn't block you. So what you ask for the user, and how many here does know what defer is? Defer or future in Java. It's essentially the same thing. You know it, right? Yeah.
So basically, what in this diagram, part of the reason why the diagram's complex is because what's going on in that API communication is complex.
Yeah.
Now, one of the things I think it's quite important to think about is that what you've done here by doing a diagram, right? One is it helps you explain it to other people, but in the act of drawing the diagram, it probably also clarifies in your mind exactly what's going on.
Yeah.
Right? Now, what we want, so one of the things that I don't know if we talk enough at university about is that part of the reason why we want you to write up reports and why we want you to write comments is not just so that we can see you've done something, right? Is that we have this belief that the process of linearizing your thought into stuff you can write down will make you think about it in a new way and potentially solve problems, right? So when we get you to debug by explaining solutions to your cat or by drawing a diagram, if you were having problems with code, the drawing the diagram will help you think about it in a new way, right? So rather than just seeing drawing diagrams as something you have to do to finish a report, right? Actually treat it as part of the development process, and it's another way of thinking about the problem, right?
Yeah.
So yeah, and once you get asynchronous, it's really hard to hold it all in your head, right? Because it gets complex like this, and complex dependencies.
When having a large asynchronous system or a system with many threads, how do you actually go about debugging it and validating it in a proper way?
So you what's your approach to doing Golang in that way?
So there has been a change to Golang recently, where the debugger just crashes. So you can't debug it in a normal way. So what I had done is simply print line. Yeah.
Okay, so actually, interestingly, so 20 years ago when I was a student, we were talking about debugging, and one of our professors had said, no professional uses print line, all professionals just write use cases and test cases. And I said, I'm not entirely sure that's true, because I talked to some developers, and occasionally they still use print line because it's a useful way of just kind of extracting data in the most basic level that just works, right? It tends to be good if you're trying to understand the exact flow, right? That you actually care about each step, then print lines make sense, right? If you're caring about doing an overall test and testing it systematically or doing regression tests, then print lines aren't particularly useful for that because you have to read so much, right? Because it's nice to automate tests so you don't have to read your output constantly, right? But yeah, when debuggers crash, you then need to go to a step-through debugger, and if you don't have any step-through debugger, you do a bunch of print lines. One way I've done testing of multi-threaded code, when you have a team of developers, right?
and it seems a bit odd to do, but you actually role play it, right? You give, each of you take the role of one of the threads or one of the processes, right? And then you just have your information and you start pretending to be that thing, right? And you just send information back and forth, you talk to each other as if you are 6 different threads, right? And just try and work out what communication is going where and make one person responsible for one thread, right? So if you've got a kind of task parallel job, because in parallelism we talk about data parallel and task parallel. So data parallel is the same task run on a lot of data, right? So GPUs, when you're doing graphics processing, are usually the same thing done to every pixel, right? So that's data parallel. It's the same task run on massively parallel data. Task parallel usually is what games do. So they have an AI component, they have a networking component, they have a physics system, they have a sound system, they have a user input management, and so they have all these separate tasks that are all doing different things at different times, right? So for a task parallel, you give each of you a different task and pretend to be that thing, and see where you get miscommunication happening, and you try and be as mean to each other as possible, right? So it's good if you try and actually break each other's communications by interrupting and doing things in like bad ways, and that's a way of kind of simulating multiple task running. So that's a very physical way of doing it, and just try and get what's going on in your head. Generally, if you're looking at how do you debug race conditions, right? Because that's the biggest issue with multi-threaded environments is the order in which things complete changes, and so if it succeeds in one order and fails in another order, then you've got a race condition going on somewhere, where if one thing finishes before the other, it's okay, but if you get it the wrong way around, it fails. One of the ones we standardly had with students developing JavaScript web pages is when you do it locally, all your images load immediately, right? Because they're on the local machine. When you put it on your server, suddenly I download stuff and now I've got asynchronous loading happening in the background of those images. I rely on those. I then create an object that relies on that image. It's not here yet, so I create a blank object. It arrives, I don't do anything, and now I've got something that isn't working, right? Because that image wasn't there when I created the object that refers to it. And so you have to deal with a whole bunch of callbacks that say, okay, after I've loaded all the images, then create objects from those images, right? So that's one of the classic ones we had with loading and loading race conditions. But anytime you're using an API like this, you're gonna, unless you do it properly, you'll get race conditions. What we tend to do is you mock things and you create a really bad, you can also use things that create bad network environments. And so you have a fragile network DLL driver where you can push and it will drop like every second packet. Right? So it's a testing driver that pretends to be a network driver that is really, really terrible. Right? And then you can test it in a fragile environment. The other way is we've added delays to things, right? So you strategically have a debug delay where you just set it running with your test cases, and you run your test cases many, many times, and with a random delay put into the program, so it will wait 3 seconds before it responds, just to see if your program breaks. Right? So you systematically slow parts of the program down to see which race is gonna, if there are any race conditions that will make it break.
There is one thing I have done to test the asynchronous code. When I do caching, everything that comes in from the Discord API needs to be cached. But since you do a event-driven approach, every reactor or listener needs to have the data that comes directly from the API, but when you add it to the cache, you have pointers. So if there comes an update as you're dealing with the object and the cache gets updated, every other object in your platform or server or application will get updated as well, and it can, break everything. That's the erase condition. So in the caching, what I've done to test this is that I simply created a user, then you mocked that it comes into the cache, gets stored there, and then I make sure that if there comes, say, update to the cache, it does not break the old copy. And the way I've done this is to simply do a timeout.
Yeah, a sleep and a timeout. Yep.
So you have, if the scenario is, say, you get the new user and you add it to the cache.
So what was the 111111111?
Yeah, that's just a random Discord ID, a snowflake.
Right. Okay.
Right.
So
Just something random, so I can be
so how are you
certain.
using it? So right. Yeah. So you create a new snowflake with that ID, and that's being used for testing purposes.
Yeah.
Yeah.
So it's just a partial object.
Yeah.
Add it to the cache, and then you. How many here does actually know the reactor pattern or proactor? Event observer. Yeah, okay. So, can you help me? Just explain the pattern.
For the reactor, so,
Yeah.
basically the observer pattern, which is what it's trying to do. So yes, what you're doing is you are registering yourself as a callback. So and you'll listen, and when you hear something, you'll respond. Right?
Yes.
So when you've got, if you're doing a socket, so this will be, if you're listening to a socket, you could listen to a socket. When something comes down the socket, you then respond to that. Right? Now, if you've not got network, if you're just doing it locally, you can register yourself with some event handler, and that will fire everybody who's registered for a particular event. It'll send that event to everybody there, and they can respond to that. Now, that's within code. When you move to being on the network, you're looking at sockets which are listening to a port. And so if I've got an echo server, I could ping it, and it will ping back saying, yes, I'm alive. Right? So once you've gotten a live ping, you could then do other responders. Right? So it gives you that pattern of, I'm listening, I'll then respond to you.
Yeah.
Yep.
So yeah.
Yep.
So now you have a listener. It's really crucial that the data it gets doesn't change. If there are some new event or new changes, you need to have a separate listener for that. Does that make sense? Okay. Yeah. And that's essentially what I've checked in the caching, because the caching is a layer between the Discord event and the listener or handler that you run. So since you're dealing with pointers and you keep caching them, once you get the new event, which say if a guild was created, you deal with it, put it in the cache, and then you get a new event which changes the guild at the same time you're dealing with the guild object. The cache will get updated, and then it will point to the same thing. So that's essentially what I'm testing here, down here. That was kind of what I was trying to explain.
So, caching. When you when you're playing video and you're buffering, you get that buffering of having to buffer video frames, right? There's a deal of what do you do when you drop, they fall behind, right? Now, for different systems, if you have a system like TCP/IP, you have to get every packet in order to reconstruct a file, right? So if I'm sending you a file of 100 items, and I'm sending you item 1, item 2, item 3, item 4, and you miss item 5, and then I give you item 6, you won't reconstruct a zip file correctly if it was broken down into 100 parts. Right? If I was streaming video, I could just show you the most recent video, and whatever most recent thing is fine. Right? But for Discord, having a proper cache means that I'm caching all of these messages, which, because if I miss one, then my cache might get, my processing might get broken, and I won't be responding properly. Yeah.
Yeah.
So yes, you have to make sure you cache things correctly, and so you can respond to all of the requests that Discord sends you, or they'll block you because you're not properly dealing with data, right? Because it wants to guarantee that if I send you something, you're going to respond to it. So, which also means if your program hangs, it just stops responding entirely if it just hangs. But yeah, then it can expect to hang. Yep.
Have you used a caching library, or have you built a cache?
I just wrote everything from scratch. It's been kind of a pain since you're dealing with a shared resource within a asynchronous environment. But the way I've handled it is that everything is a copy. Or, hang on, everything between the reactor pattern layer and my cache layer is copied. Wait, what was the question?
So okay, you wrote the caching yourself rather than use the library that did it.
Yeah.
So we were looking at this if you were doing image handling, right? So on some of my programs I've used video handling, right? And you get the video image in, and I wanted to actually handle every frame. And so we had a circular cache. And so I would be dropping things into the cache and moving along. So I'd be processing one I have, the new one came in, and I'd put it into the buffer up one, right? Now, there's two ways of dealing with it. When you're dealing with video, if you know you're going to take a long time to process this one, then you could just be basically dropping frames. Every time a frame comes in, you put it into the most recent buffer, and as soon as I want to change and I'm finished, I'll change my pointer to this one, and then change the input pointer to the other one. So I've just got these two pieces of memory, and I just kind of double buffer, right? So I have two buffers. I'm processing one, and you're updating the other to the point where you're done, and then I will jump across and point you back to my old one and do that as an atomic switch. Right? So that's a standard. That's what your graphics card does, right? When you're doing double buffering on your graphics card, what's actually happening is it's writing to one buffer and showing the other one to screen. And then when I'm finished writing this one, it goes, right, flick, bang. Right? And now I can write to where it was showing, and I can show the current one. Right? So I can flick back and forth. So that's a single cache location. If you need to have proper buffering, then you create an array of cache locations. And you can do circular arrays if you know you hope that you're going to not have to use up too much memory. You create a circular cache, and it says 10 frames in it, and if you use up your whole cache, you might decide to, my program's stopped responding, right? And I'm just going to have to stop now, right? And so hopefully you never use up your 10, right? And you want to be able to process faster than stuff's coming in, right? Otherwise you have to rate limit and say, I'm getting too much. Slow the input so I can process it more, right? So that's kind of how you balance off some of these things. But yeah, so you could rate limit to get less data in so that your cache doesn't get too large. Now, do you have a single item cache, or do you use multiple? Do you have a vector of items?
You mean?
So when you're caching, you cache to a shared object, and then you flick that, or do you have an array of things you've cached and are processing, or?
So in my cache, or the main reason I wrote it from scratch is because you need to cache all the Discord users, you need to cache the channels, and every channel can have a Discord user as well. So by writing it myself, I can make sure that the user in the channels and the users in my user cache layer points to the same object in memory. And that becomes really useful if you have, say, a guild which has, 50,000 users, and you need to cache those users on your user cache layer as well, because then normally if you use the library, there will just be a copy. But by doing it by myself from scratch, I can make it so it points to the exact same reference and save half the memory.
But you'd have to be careful if they update the cache, the guild, then you could have some cache overwriting happening.
Yeah, and that's another point. By doing everything as a copy, I can make sure that my pointers never changes the address. So I always point to the same space. And then I only need to update one place instead of the guild, the channels, the messages, and the users.
Right.
If I get a user change update.
Yep. Okay. So most of this code you've been commenting quite a bit. Oh.
Yeah, it's a lot of to-dos.
There's a bunch of to-dos in those comments. Now, one of the nice things, so when you've got the to-dos, do you leave your to-dos there once you've done it, or how do you do you do with your to-dos once you've done it?
Once I'm done with the to-do, I just remove it.
Right. So this is again an interesting thing that you could potentially do. That if you go to the to-do, right? You go to where you have a to-do. The thing about a to-do is it's a comment about what the code is supposed to do, right? What needs to be added to this code.
Yeah.
So actually leaving your to-dos in once you finish them, and then leaving them in as a description of what this code does, right? Rather than deleting them, because then you lose some of the framework, right? So you can imagine a to-do list kind of is the framework of how you plan to do something. And then as you fill in that framework, your to-dos become, what does this do, right? So instead of to-do, it's kind of this does, right? Or it's that kind of thing. So you can leave those in. So here you've got like to-do caching emojis, right? So you've got guild emoji key update. So this is now done?
No, it's not done.
Right, because you're not caching the emojis.
Yeah, I'm just parsing the byte array coming from Discord as a JSON. And then I'm triggering all the event listeners.
Right. So here, once you've added in at the bottom here underneath this to-do caching emojis, you could just remove the to-do bit and leave it as caching emojis.
Yeah.
Right. So it becomes kind of auto-commenting in a sense of as you undo your to-do list, it leaves that structure there. Right. Because deleting that additional work kind of makes it look like it came out of thin air, right? Yeah. Which, as a professional, it didn't, right? You came out with from a plan. Right? And that's partly why we talk about commenting. If you make your to-do lists, that is part of the commenting, right? You can imagine the comments are always going to be to-dos, right? So, because if you put in a whole bunch of comments about what your code is going to do, and you just say, it'll do this, it'll do this, it'll do this. So here, it would just be the comment where they're all gone. You just have a comment of what it's going, this to-do caching user update. This would just say caching user update, right? Now, when it's not finished yet, you could leave the word to-do in front of it, and when it's done, it's the comment on what that code does.
Yeah.
Right? So think about how you can use that approach to improve the commenting in your code, right? Because it should be a tool to help you think about your code. Just like the diagram, drawing the diagram will help you understand what's going on in your code, right? Rather than just being something we tell you to do because it's part of an assignment. Okay, questions about that?
What else about like if you have to-do list when you have something that needs to be done afterwards. If you have a part of code that needs to be like marked or here's a special point, make sure that you read this. Like I tried to find something that similar to that, but didn't find it. Because somewhere in my code, you shouldn't run anything before the ASCII task is finished. So you should all the code that should be done after that just comment it out and went after that. So just trying to find a way to comment that say hey, this section is too important, this commit is too important?
Okay, so usually I would use the word critical, right? As like comment that this section is critical, and could be the word critical with something like must be in this location or must be before blah.
When auto-generating documentation, you could use some code word in that comment, and most auto-generated documentation frameworks also support HTML formation. So you can, for example, use a B or a bold and just say critical or required and your statement in it. And when people review the documentation, it would be stand clearly there instead of a method inline comment saying that this must be done before calling this or something.
Yeah, so you can raise, so if using auto documentation, because as you say, the bold I think is Markdown as well. So yeah. it's I think they mostly support Markdown. So I certainly know that the READMEs and GitHub and GitLab and things use Markdown. So you can use the bold tag.
The Java doc supports HTML.
It supports full HTML.
Yeah.
That's nice. So at least it supports Markdown, and some will support Java that will support full HTML. Then you can add bold to a word like critical, right? To do is fairly standard, I think. So critical I've seen used to mean that kind of thing, right? So, and bolding it would help. Anybody else? What would you, if you were reading code and you saw a comment that was, what would you like? What would you want to see as a comment that was critical, or be very careful of changing this? So what would, instead of the word critical, is there another word that would be better? Warning? Maybe it could be warning. I know that we had some code, dragons be here was used as the don't touch. So yes, dragons was the key word for don't touch this code, it will destroy you.
You can enforce that the problem will never arise. So, say instead of supplying a library, you supply a stub usually. So, as a programmer, you can never actually change that specific code bit unless you try to fork it. And the other thing is on the problem of dependency injection. Say you're creating an object, but then you find out that that object needs another object, which needs another object, and that chain. So you kind of enforce the user to never misuse your code.
So often you'll see also people will do like either they can add asserts that will say, you know, if this thing doesn't exist, either crash or don't do any, like wait for this thing to exist, right? And do so you ideally you'd have a sleep with a call, like waiting for a particular callback or something like that would put you to sleep until something arrives. And so yeah, often you can code around them, right? And yeah, as you say, if you can put it out into a library, right? So whoever is coding against your, like adding stuff to your code, doesn't look at that part of the code or isn't allowed to change that part of the code, then you can enforce particular behaviors, right? Without just making the code available. You lock it up. Right? And that's also when we're talking about making libraries. If there is code you want to lock up, but you want to share the functionality with the rest of the team, then doing it as a library is one way of doing that.
Yeah, I was just going to say that it becomes relevant again in internal teams, because then everyone actually has access to you know, to the library.
Yeah. Yeah. Right. My wife is ringing me to tell me that I'm supposed to let you guys go. Because it's...
You're supposed to be somewhere else.
No, I think she wants me to let you guys go because it's Friday afternoon. No. Things, other things. Yep. Oh, we'll grab them. Yep. Okay. Yes, in my office. Yep, I'll bring him on. Yep. Yes.